Hello everyone. As you have seen in the earlier video how the ripple voltage occur when we simulated the model. Now there are two effective ways to reduce this ripple voltage. Either you can reduce the ripple voltage by reducing the ripple current of the inductor or by using capacitor at the output of the circuit. Here we have used a capacitor which acts as a filter. In this simulation, electrolytic capacitor has been used, which acts as a filter to reduce the ripple voltage. Now, what do you mean by electrolytic capacitor? Electrolytic capacitor or ECAPs are polarized capacitors whose anode is made of a metal that forms an insulating oxide layer. Now, this oxide layer acts as the dielectric of the electrolytic capacitor. Now, knowledge of ripple factor is essential while designing the values of capacitor. So, it is as you have already understood that how capacitor can reduce this. So, designing or applying rating for the capacitor is essential for us. Now, capacitor rating can be found by using ripple voltage formula. There is a relation that you can see. VR is equals to Vs upon 2 FCRL. Now this is a standard relation where V of S is peak of input voltage. VR is obviously ripple voltage. F is again frequency and C is capacitor. RL is load resistance. Now, by substituting the values that you have seen from the video second from the yellow probe, the value of capacitor from the above relation can be now found. From slide number 9 or from the earlier video, the values for the above parameters are VR is 14.5, Vs is 13.1, frequency 50 Hz and so on. So here capacitor value when you solve it comes out to be 5 millifarad. Now, see at the output, I have connected capacitor C1 of 5 millifarad, and as soon as I connected 5 millifarad capacitor at the output side, the VPP value got decreased, that is the ripple voltage got decreased and it has become 1.20. As if you remembered earlier, it was 14.5 volt which was high in amount. And as soon as I run this, I am getting such kind of waveform. Now you can see the blue line, the upper line, which has now decreased, and you're getting a pure sinusoidal waveform somewhere. You can see the yellow box at the output VPP is 1.22 volts. It has now reduced a lot. Now here I have done a comparative analysis with and without capacitor. If you do not remember the earlier waveform, here the comparative analysis I have taken into account. The first waveform is without capacitor. The second waveform is with capacitor. You can see the difference. As seen from the above simulation, as soon as we connect the capacitor, ripple voltage got reduced, which just now you have seen. So this is the method to reduce ripple voltage from the output. As the aim is to design power supply of 5 volt by 1 ampere, we will now see the next video about how can we achieve this. But before going through the next video, I have uploaded certain quiz questions for you. There are 5 questions, very basic, very simple questions. Go through it so that you'll get to know that how much you have understood. Thank you.